we're looking at the laws of indices. When you have numbers in index form, or you have questions given to you in index form, you can use the laws of indices to simplify such questions. Okay, so let's write laws of indices are rules for simplifying expressions involving power of the same base. Okay, so the laws of indices are rules for simplifying expressions involving power of the same base. So when you have an exponential expression, it contains a power and a base. So these are two components of an expression in exponential form. For example, if you have 2 raised to the power 4, okay, 4 is the power and 2 is the base. Okay, so that is why we are saying laws of indices are rules for simplifying expressions involving power of the same base. This means for you to apply laws of indices, the expressions in a particular question must have the same base. Remember, this is the base. So before you apply laws of indices on any particular question, you must ensure that the basis of the expressions are the same. Okay, so we are going to look at 6 laws of indices. Then afterwards, we are going to solve some questions. Let's look at the first law of indices. Okay, so the first law of indices, number 1, is the law of multiplication. So the first law of indices is the law of multiplication. Now, if you have 2 expressions having the same base multiplying themselves, what does the law of indices say? So if I have a to the power of m multiplying a to the power of n, what does the law of indices say? So these are the bases. The base here is a, the base here is a. This means that the bases are the same. Remember, the bases must be the same. So here the bases are the same. So since the bases are the same, the law of multiplication says when the bases are the same, you add the powers. Okay? When the basis of an exponential expression or 2 exponential expressions are the same, what you have to do is you add the powers. The power here is m, the power here is n, so you are going to pick one of the a and then you do m plus n. That's what the law of multiplication of indices says. Let's look at an example. An example here is 2 to the power of 5 multiplied by 2 to the power of 2. 2 to the power of 5 multiplied by 2 to the power of 2. What we are doing here, we are trying to apply the law of multiplication. Remember here, the base here is 2, the base here is 2. The base must be the same. So the bases are the same. Therefore, we can apply the law of multiplication of bases. Okay. So here we are going to pick one of the 2 bases which are the same, so we'll pick 2. And then the law of multiplication says we should add the powers. So this is going to be 5 plus 2. Okay, so 5 plus 2 is going to give us 2 to the power of 7. Okay, so when you have a situation like this, where you are expected to multiply 2 exponential expressions having the same base, all you need to do is add the powers. Okay, so when we start solving examples, you are going to see how we can apply in real life situation. Okay, so let's look at the second law of indices. Second law is law of division. Law of division. Okay, so when you have a to the power of m divided by a to the power of n, what does the law of division say? The law of division of indices is opposite to the law of multiplication of indices. So when we are multiplying, we added the powers. Therefore, when we are dividing, we are going to subtract the powers. So when you are having a division here, remember the bases are the same, then you are going to subtract the power. So this is going to be a to the power of m minus n. So that's what the law of division states. When the bases are the same and you're dividing, all you need to do is subtract the powers. Okay, let's look at an example. 2 to the power of 5 divided by 2 to the power of 2. So applying this principle here, this law, which is you pick one of the two bases which are the same, and then the powers you subtract. So we have 5 minus 2. We have 5 minus 2. And 5 minus 2 is going to give us 3. So this is going to be 2 to the power of 3. So this is the application of the second law of indices. So we are going to the third law of indices. So law number 3, we have law of brackets. Okay, so when you're having a situation where you have a to the power of m multiplied by n, or bracket close n, okay, what does the law state in this situation? This means these two values, because there's a bracket here, remember bracket in mathematics represents multiplication. Okay, so this bracket here runs across the power, so it affects the power. So you're not going to add, but you're going to multiply. So it's m multiplied by n. So in this case, where a bracket is involved, you are going to multiply the powers. So if you have, for example, 2 to the power of 5 bracket to the power of 2. So in this situation, you are not going to add 5 and 2 together. What you are going to do is you're going to multiply 5 and 2. So that will give us 5 multiplied by 2 will give us 10. So this will be 2 to the power of 10. Okay? So in the law of bracket, when you have this situation where an exponential expression is in a bracket, then you multiply this power and this power. Let's look at the next law of indices. Let's look at the next one. So we've looked at the first one, which is the law of multiplication. We've looked at the law of division. And now we've looked at the law of bracket. So let's look at the fourth one. Number 4, law of negative power. The law of negative power. This situation arises when you have something like this, a to the power of minus m. A to the power of minus m. So this negative simply means an inverse of a to the power of m. This negative simply means an inverse. So what does it mean? If you have this marker here, this is the top side and this is the bottom. The inverse of this is simply turning this upside down. So when you have a to the power of minus m, remember every number including a is same thing as a all over 1. So to eliminate this negative, you just simply turn this to become 1 all over a. Okay? So a to the power of minus m is the same thing as 1 all over a to the power of n. So this is the law of negative power. This is the law of negative power. So if you have any exponential expression where you have a negative power, for you to eliminate the negative power, you have to write down the inverse of a to the power of m. Let's look at an example. If you have 2 to the power of minus 5, 2 to the power of minus 5. So 2 to the power of minus 5 is the same thing as 1 all over 2 to the power of 5. Okay, so 2 to the power of minus 5. When you want, in order to eliminate this negative here, you have to write the inverse of 2 to the power of 5, which will be 1 all over. So this negative is the same thing as 1 all over. Okay? So if you have this 2 to the power of 1 all over 2 to the power of 5, 2 to the power of 5 is 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 2. And that will give us 32. So this is the same thing as 1 all over 32. Okay? So we are going to apply all these things when we are actually solving questions involving indices. So let's go back to number 5. Law of power of 0. You can watch this video again on my YouTube channel. So let's look at the law of power of 0. So a to the power of 0 is equal to 1. A to the power of 0 is equal to 1. This means that 2 to the power of 0 is equal to 1. 3 to the power of 0 is equal to 1. 100 to the power of 0 is equal to 1. Any number for that matter to the power of 0 is equal to 1. The sixth law of indices. The sixth law of indices. Law of fractional power. So law of fractional power. We have a to the power of m all over n is equal to n a to the power of n. So what does this imply? What does this imply? This means that when you have a base to the power of a fraction, this is the base a to the power of fraction. The numerator of that fraction is a power, and the denominator is a root. Okay? That's why you have n root of a to the power of m. So a to the power of m divided by n is the same thing as n root a to the power of n. Let's give an example. Let's look at an example. If you have 2 to the power of 5 all over 3. 2 to the power of 5 all over 3. This is the same thing as, remember, the denominator is a root, so we have cube root, and the numerator is a power, so 2 to the power of 5. Okay, so whenever you have a situation like this where the base is to the power of a fraction, you know that the numerator of that fraction is a power and the denominator of that fraction is a root, which is cube root. Okay, so these are the 6 laws that will help us in solving questions involving indices. So we are going to use these laws to find out the solution to some simple questions involving indices. Okay, so let's look at some questions now. So I'm going to leave this statement here, but we are going to solve from this session. So example, simplify 27 to the power of minus 2 all over 3. 27 to the power of minus 2 all over 3. So we are going to apply the laws of indices to this particular question. Now, looking at this question here, let's see how many laws can be applied. Let's see how many laws can be applied. The first law I'm seeing here that can be applied is the law of negative power, because we have to eliminate this minus sign in the power. Okay, this means we are going to apply the fourth law, which is the law of negative power. The second law I can see here is in this particular expression here, we have a power that contains a fraction. So we are going to apply the law of fractional power. Okay? So we are going to apply two laws in this particular question. The first law we are going to apply is the law of negative power in order to eliminate this negative in the power. So remember, the law states that a to the power of minus m is the same thing as 1 all over a to the power of m. So that's what the law of negative power states. So let's apply it here. This, which looks like this, converting it to this form will become 1 all over 27 to the power of 2 all over 3. Okay, 27 to the power of 2 all over 3. So we have been able to apply the law of negative power to move this expression from this to this. The next law we are going to apply is the law of fractional power. This law states that when you have an expression in the form a to the power of m all over n, the numerator of the power is a power and the denominator of the power is a root. This will make this expression to become 1 all over root, which is cube root of 27 to the power of 2. Cube root of 27 to the power of 2. So what is cube root of 27? The cube root of 27 is simply a number that will multiply itself 3 times. Remember, it's a cube root, not square root. The cube root of 27 is that number that will multiply itself 3 times to give you 27. So what can that number be? That number is 3, because 3 multiplied by 3 gives you 9, and 9 multiplied by 3 gives you 27. So cube root of 27 is equal to 3. So this is going to be 1 all over 3 to the power of 2, because the cube root of 27 is equal to 3. The next thing we are going to do is find out 3 squared. 3 squared is 3 multiplied by 3. 3 multiplied by 3 is going to give us 9. So our final answer to this question is 1 all over 9. That is the simple answer to this question. So in this particular question, we apply 2 laws of indices. Let's look at another question. So if you have example, simplify 10 to the power of minus 6 to the power of 3. Okay? So this is another simple example. The first thing we need to identify, we identify the laws of indices that we have to employ. So the first law of indices that we need to employ is the law that will help us to eliminate this bracket, and it is called the law of bracket. This means that a to the power of m bracket n, the power here is going to multiply the power here, so this will become a to the power of m multiplied by n. So this is the law we are going to apply first, which is the law of bracket. So let's apply it to this question that we have. Let's apply it to this question that we have. So this is going to be 10 to the power of minus 6 multiplied by 1 all over 3. Okay? So negative 6 multiplied by 1 all over 3. 3 is going to cancel itself 1. 3 will cancel out negative 6. We have minus 2. So this is going to be 10 to the power of minus 2. Okay? So we have applied the law of bracket to this question. The next law we are going to apply is the law of negative power, because we have a negative value here in the power. Remember, the law of negative power states that a to the power of minus m is the same thing as 1 all over a to the power of m. So that's the law of negative power, which this looks like this. So we're going to transform this to look like this. So that is the law of negative power. So let's do that. This will mean 1 all over, sorry, not a, 10. 1 all over 10 to the power of 2. And 1 all over 10 to the power of 2. 10 to the power of 2 is 10 multiplied by 10, which will give us 1 all over 100. So this is the simple answer to this question. So let's look at another example. We have 27 to the power of 2 all over 3 multiplied by 81 all over 16 to the power of negative 1 all over 4. Okay, so let's see how to solve this. So these are two exponential expressions. So looking at 27 to the power of 2 all over 3, this tells us that 3 is the root while 2 is the power. So this can be rearranged using the law of fractional power. So here we're going to apply the law of fractional power. But before we apply the law of fractional power here, we are going to apply the law of negative power over here. So let's start with this. Let's apply the law of negative power. The law of negative power states that if you want to remove the minus sign in the power, all you need to do is write the inverse of the base. The inverse of the base here is 81 all over. Sorry, the base here is 81 all over 16. This means the inverse of that is simply we flip this upside down. What is in the numerator comes to the denominator, and what is at the denominator comes to the numerator. So this will be 16 all over 81. Once you write it this way, the negative is eliminated. Okay, so let's write. So this will give us 27 raised to the power 2 all over 3 multiplied by 16 all over 81 to the power of 1 all over 4. Okay, to the power of 1 all over 4. So in this situation, our root here is 4. Okay, so the root means we find a number that multiplies itself 4 times to give you any of these. Okay, so let's look at this. Here we have cube root of 27 to the power of 2. Remember here 2 is the power and 3 is the root. So we have cube root of 27 to the power of 2 multiplied by. Now we are looking for this one, which is 4th root of 16 all over 81. Okay, the power here is 1, so there's no need to write it. So we are going to look for a number that multiplies itself 4 times to give you 16, and we're also going to look for a number that multiplies itself 4 times to give us 81. So first of all, let's go back here. Cube root of 27 is 3. The number that will multiply itself 3 times to give you 27 is 3. 3 multiplied by 3, 9. 9 multiplied by 3, 27. So we now have 3 to the power of 2 multiplied by. What number will multiply itself 4 times to give us 16? That number is 2. 2 multiplied by 2, 4. 4 multiplied by 2, 8. 8 multiplied by 2, 16. That means 2 is going to multiply itself 4 times to give us 16. So at the numerator we have 2 all over. What number will multiply itself 4 times to give us 81? That number is 3. How do we know? 3 multiplied by 3, 9. 9 multiplied by 3, 27. 27 multiplied by 3, 81. So here we're going to have 3. Okay. So over here we have 3 squared. 3 squared is the same thing as 3 multiplied by 3, which is 9. So we're going to have 9 multiplied by 2 all over 3. Okay. Let's bring down the denominator of 1, because every whole number has an invisible denominator of 1. So at this point we can cross out 3 here, 1, 3 here, 3. So what will our final answer be? Our final answer will be 3 multiplied by 3, 6, all over 1 multiplied by 1, 1. Therefore our answer is 6. Very simple. Okay. So this is how to apply it in this particular question. Let's look at another question. This is quite simple. So if we have example, simplify 11 whole number 1 all over 9 to the power of minus 1 all over 2. In this particular simple question, the first thing we have to do is convert this mixed number to an improper fraction. That's the first thing. That's the basic thing you have to do. Let's do that. Converting this mixed number to an improper fraction. So to do that, you're going to multiply this denominator by the numerator and then multiply the denominator by the whole number and then add the numerator. So 9 multiplied by 11 is going to give us 99, and 99 plus 1 is going to give us 100. So this is going to be 100 all over 9 to the power of minus 1 all over 2. So that was the first thing. Then we can now eliminate the minus, as Remy had said. Okay, we can now eliminate the minus. We eliminate the minus by writing the inverse of this base here. The base here is 100 over 9. So for us to eliminate the minus in the power, we have to write the inverse of 100 over 9, which is 9 all over 100 to the power of 1 all over 2. So solving questions on indices is quite simple. It's not difficult, it's very simple. All you need to do is follow the laws of indices. So now we've gotten the inverse of this. So we have 9 all over 100 to the power of 1 all over 2. The next thing we are going to do is apply the law of fractional power, which states that when you have a power that is a fraction, the numerator is a power and the denominator is a root. This means square root. So what we are going to have is square root of 9 all over 100. Okay. So what is the square root of 9? What number will multiply itself to give you 9? What number will multiply itself to give you 9? 3 will multiply itself to give us 9. So we have square root of 9 is 3 all over square root of 100. What number will multiply itself to give you 100? Square root of 100 is 10, because 10 multiplied by 10 will give 100. So we have 10. So this means the final answer to this question is 3 all over 10. Very simple. Very simple. I like to see what the answer will be. I like to write the question and let's see how many persons can give the correct answer. Let's look at this simple classwork. Let's see how many persons will be able to give the answer to this question. So I always come live every Wednesday at 8 p.m. Nigerian time. 8 p.m. Nigerian time is 7 p.m. UK time. 8 p.m. Nigerian time is 9 p.m. South African time. It's 7 p.m. Ghanaian time. So Nigerian time is GMT plus 1. Okay, so every Wednesday I come live and also every Friday. So try out this question. 64 to the power of 3 all over 2. What will be the answer? 64 to the power of 3 all over 2. 64 to the power of 3 all over 2. Example. Simplify. 8 to the power of 1 over 3 times 5 to the power of 2 all over 3 divided by 10 to the power of 2 all over 3. Okay, so let's look at this question. This is also a simple question. Let's look at it together. So we're going to apply the laws of indices here. But before we apply it, let's look at these numbers we have here. We have 8 here. Remember, for you to apply the laws of indices, let's look at it. Laws of indices are rules for simplifying expressions involving powers of the same base. So here, there's an issue here. Okay, the issue is the base here is 8, the base here is 5, the base here is 10. So we cannot apply any law of indices because the bases are not the same. Therefore, we need to manipulate this expression in order to get the bases to be the same. Okay, so we need to manipulate this expression in order to get the bases to be the same. First number we are going to manipulate is 8, because 8 is the same thing as 2 to the power of 3. 8 is 2 multiplying itself 3 times. 2 multiplied by 2, 4. 4 multiplied by 2, 8. So instead of having 8 here, we can have 2 to the power of 3 bracket 1 all over 3. Okay, times 5 to the power of 2 all over 3 divided by. Now, we have a base of 2 here, we have a base of 5 here. So we need to manipulate 10. 10 can be divided into 2 factors. 10 is the same thing as 5 multiplied by 2 or 2 multiplied by 5. So instead of writing 10 here, we can write 2 times 5 to the power of 2 all over 3. 2 multiplied by 5 is the same thing as 10. So we still have the same thing. The only thing is that we have expanded 10 to become 2 multiplied by 5. Why did we expand it? Because we saw that the base here is 2, the base here is 5. We are trying to ensure that we get same base. Okay, that's what we are trying to do, so that the bases will be the same. Good. Next, we are going to divide, we are going to separate this. If you have something like this, a plus b to the power of n, okay, this is the same thing as a to the let's use this times here, multiplication. A times b to the power of n. This is the same thing as a to the power of m times b to the power of m. Okay, so when the powers are the same, we can just bring the bases together and put the power outside. Okay, so let's look at here. We have 2 times 5 to the power of 2 all over 3. It looks similar to this, a times b to the power of n. So what can we do? We can bring out 2 to the power of 2 all over 3 and bring out 5 to the power of 2 all over 3. But before we do that, let's look at here. Let's look at this. The law of bracket says when you have a bracket, you multiply the power. So you multiply 3 times 1 all over 3. Let's write it 3 times 1 all over 3. This is 3. 3 is the same thing as 3 over 1. So 3 will cancel out 3. So this will give us 2 to the power of 1, because 1 all over 1 is 1. 1 all over 1 is 1. So this will now become 2 to the power of 1 multiplied by 5 to the power of 2 all over 3 divided by, let's separate this now, just as we had there and we got here. Let's separate this. So this will be 2 to the power of 2 all over 3 multiplied by 5 to the power of 2 all over 3. So now we are getting close to this. Remember, same base. Now look at these two. They are same base. And look at these two. They are same base. Okay? So we can continue. So this can be written as 2 to the power of 1 all over 2 to the power of 3 all over 2. Sorry, 2 all over 3 times 5 to the power of 2 all over 3 divided by 5 to the power of 2 all over 3. Okay? So all we did, we just cut through and separated them. So these people went their own way and these people went their own way. So at this point, you can apply the law of division. When you are dividing two exponential expressions with the same base, they have the same base, you subtract the powers. So this will now be 2 to the power of 1 minus 2 all over 3. So we are dividing. This is the second law. For those that were here when we started, this is the second law. When you are dividing two exponential expressions with the same base, you subtract the powers. So 1 minus 2 all over 3. So we have applied it here. We also apply it here times when you are dividing two exponential expressions with the same base, you subtract the powers. So here will be 5 to the power of 2 all over 3 minus 2 all over 3. 2 all over 3 minus 2 all over 3. What is it going to give us? 0. Somebody said 0, correct? So 2 all over 3 minus 2 all over 3 will give you 0. So, but 1 minus 2 all over 3. 1 minus 2 all over 3. Let's do it here. 1 minus 2 all over 3. The common base will be 3. This is simple fraction, okay? Remember, 1 is the same thing as 1 all over 1. So 3 divided by 1 will give us 3. 3 times 1 will give us 3. Minus 3 divided by 3, 1. 1 times 2, 2. So 3 minus 2 will give us 1 all over 3. This means that 1 minus 2 all over 3 will give us 2 raised to the power 1 all over 3 times 5 to the power of 0. And from the law of indices that we studied today, where we learned today, anything raised to the power 0 is what? What is anything raised to the power 0? Power 0, 1, exactly. Anything raised to the power 0 is 1. Okay, so I'm going to clean up this part to continue. So anything raised to power 0 is 1. So this gives us 2 to the power of 1 all over 3 multiplied by 1. Okay? So anything multiplied by 1 is that thing. This means we have 2 to the power of 1 all over 3. So we can leave it like this, or we can still go further to apply the law of fractional power. The denominator is a root, so this will give us square root of 2, or cube root of 2, because it's a cube, so cube root of 2. So this or this becomes our final answer. I hope you guys enjoy the class. So for more contents like this, all you need to do is subscribe to my YouTube channel, or just follow me here on TikTok. So every time I make videos on TikTok, anytime I do live sessions on TikTok, I post the videos. Yeah, Rash Money, I'm glad for you too. So I post the videos on. Yeah, if you want to learn maths, you can just go to my bio, click on the link there, and connect with me on WhatsApp to join my WhatsApp group. Okay, so from my WhatsApp group, the students over there demanded that I should teach indices, and that's why I'm teaching indices today. So whatever the students on my WhatsApp group demand for as a topic, that's what I teach on TikTok. And that same video, I post it on my YouTube channel so that they can watch it as many times as possible. So you can also do that. Subscribe to my YouTube channel and watch my videos as many times as possible. One other benefit of joining my WhatsApp group is, from the month of March, I will be giving out gifts to the most active participants or students in my WhatsApp group. So if you want to be among the lucky winners of cash gifts and other prizes, all you need to do is join my WhatsApp group. We've come to the end of today's class. I want to say thank you to everyone, those who liked, those who shared, those who commented, and those who actually gave gifts. So thank you so much for joining. I'm so grateful. So I'll be ending the live class here. See you in the next live class, or join my WhatsApp group.